Welcome back everyone. In today's video, we are going to cover one of the most important interview questions, which is what are the cases when fine tuning is necessary and what are the cases when it's not necessary. Before we understand this, why fine tuning is not important in most of the cases, we need to understand the problem statement. Okay, so let us take hallucination as one of the problem statements. For example, you have given a prompt, maybe what is capital of US, and answer was Delhi. Okay, or New Delhi, whatever you call it. You know, factually, this answer is wrong, but LLM gives you in such a way that it's so confident on this answer. So these kind of factually incorrect answers, but confident answers, this issue is called hallucination. Okay, so this is the problem statement. We got it, clear understanding of it. Now, first question: does fine tuning solve hallucination? If someone asks you in any interview, the base answer is no. Okay, it can slightly improve factual grounding of your answer, but it's never gonna solve hallucination, and it has a lot of cons associated with it. So there is much better solution which you can use compared to fine tuning. So what is that solution? Before going to that solution, you need to understand what are the issues with fine tuning, right? First thing, obviously fine tuning is also some kind of training. So there is a lot of cost associated with it, which is GPU requirements, not as much as base training, but you still need GPUs and dataset related costs and expertise. All these things are required as well. As mentioned, you need to collect data, you need to annotate that data, and you need to go through the training or fine tuning cycle as well. And you can never know that your model is now fine tuned to the best of its ability. You should always version your model and maintain different versions of your model, which requires a lot of storage as well. Okay, or checkpoints for your model. So once all these are done, these are significant costs compared to other better solutions and cheaper solutions you have. Okay, so what is the one of the better solutions for this hallucination problem? It is RAG, which is retrieval augmented generation. Okay, so RAG solves a lot of problems you face in your daily day-to-day work, and hallucination is one of the problems which RAG can solve really well. So now the question is, how you gonna explain to interview what RAG is? So you can just remember this next diagram I'm gonna put into this slide. So just give concentration to what I'm talking about. Okay. So first thing, you always get a query. Someone is asking some question to LLM. So this query, LLM cannot directly understand in the actual English or text format, right? So basically it needs to be embedded, or an embedding needs to be generated for it. So for embedding, what you need? An embedding model, right? So that's what we are gonna show in the diagram, which is we need an embedding. Who is gonna give that embedding? It's an embedding model. Okay. Now, once you got the embedding, which is nothing but a vector, you need to find similarity with existing content which is related to this question. So maybe in your database there are around 1,000 things or million things, right? But you need to get top content which is matching with this query. How you gonna do it? Again, the answer would be cosine similarity, or there are a lot of other similarity metrics. So we are gonna cover it. So first thing is you need to query the database with this embedded query and other embeddings which are stored in the database. Now, what is the next step? A database retrieval is gonna return a lot of matched queries, but generally what you're gonna do is you're gonna take either top 5 or top 10 or top 3 based on your requirements. So once you retrieve it, the next step is you have, for example, the relevant top 5 content. You're gonna put this in the context of LLM with query. Okay, that is, LLM is now enriched with the context, and it's gonna give you, in most of the cases or 99.9% of the cases, a correct answer. So this is at the top level what RAG does. Obviously, there are considerations on vector databases, there are considerations on similarity metrics, and there are considerations on what is the best way to put this in the context. Are you going to summarize this, or are you going to put it in such a way that important points are going to be more relevant in the summarized version or not? So we are going to go in depth of this into in the future videos. So now, where does fine tuning actually work? So first is domain specialization. Okay. So for example, if you want an LLM to give very good answers to doctors when they are asking about, for example, certain disease or certain medical domain related question, then you need to fine tune that model with the domain related data. And also there are other cases as well. For example, if you want the model to answer in certain way, or you want certain outcomes to be prioritized, then for the behavior steering as well, you need fine tuning. Next, there is something called as guardrails. Okay, so for example, if kids are involved or asking questions to a model, you need to have certain guardrails or certain answer filtering before actually answering the kids, so that they are not exposed to bad things, right? So for effective guardrails or inbuilt guardrails, it's always better to have some kind of fine tuning. And later you can also have something called as external guardrails, which is once the LLM gives an output, it is also filtered again. Okay, but internal guardrails are very important. Now coming to agents, right? For example, you have a complex agentic system where multiple agents are interacting with each other, and some agents have certain tool access, right? So you might need to fine tune the agent based models to maybe call certain tools more, or to behave in such a certain way, and to take decisions in certain way. So these kind of specific use case related actions, you might need to fine tune that model as well. So these are the cases where fine tuning wins, and they kind of necessitate the cost associated with the fine tuning as well. Hopefully this gives you clear understanding on answering these kind of questions. So if you like this video, do subscribe to my channel, and we are going to make more similar videos like this in future.